like that round robin worked now properly. Here it is different, right? uh, First five are in first house, second five are in second house. When you say map by node, it will distribute to each node. One more experiment I can show you, like adding more nodes here. Is one more node I will add. Okay, 4. uh, this one, uh, see here, uh, rank 0 in first house, rank 1, first 5 are in one house, second 5 are in 04 house, house number 04, another set is on 03. It is without map by node, without map by node, right? If I add map by node, it should do round robin thing. Let me add and show that to you. Uh, map by node. Yes, 0. 1 is in different house, 03. 2 is in 04, like that. See, now it is totally mixed up. It is distributing host 1, host 2, host 3, like that. Like that, it is filling up with the map by node. And without map by node, it will fill up in the first host, then go to second host, then go to third host, like that. So there are thousands of scenarios you can try here. I can just suggest you to try few of the things using man pages. Man MPI run will give you a lot of things. How to use this one, what are the options. See here, map by core is there, map by slot is there. No local means it will not run any process in the machine where I am executing the command. So no local, if you give, it is not running anything on the node which I am running on, only in remote nodes. Oversubscribe is for simulation purposes. If you oversubscribe it, for example, it is also very useful command that you need to try. Oversubscribe. Home. See, I have given 20 here, but in the host file, right, we we have only lesser. How much it is? 15, 5, 5, 5, 5. 15 is there. But even if I give 20, it is running because it is a simulation kind of mode. Uh, Usually, when we are trying in the research lab and all, we don't have big computers, normal computers and all, right, with few CPUs. So I can simulate hundreds of CPUs using oversubscribe command. Um, okay, like something like this. Home oversubscribe. Let me try 200. See, 200 processors. This is the advantage. This is highly useful in simulation kind of environment where we have testing all the things, algorithms and all in the test machines. with the oversubscribe, we need not have to have supercomputers when we are doing some POC models and all. That is the best way of doing that. Let find see, you can run as many processes. How many people are there? See, all are saying hello to each other and communicating with each other. Yeah. So uh, I have almost covered today's session. Here, basic MPA Hello World program execution, how to compile and run the program, how to compile MPICC when it is a C program, and when it is a C++, there is a option capital letter CC, and Fortran I have shown MPI F90. There are 3 types of Fortran codes you can write with the different versions. How to run the program? You have compiled Hello World program. Then how to run that one? Use MPI run command. MPI run command has thousands of options. I have shown very few of them. Uh, and we have covered map by node to run in a round robin fashion. If I don't give, it will pick up randomly, or it will fill up all the nodes and go to next nodes like that. Map by socket is there, map by core is there. All these things you have to experiment yourself in after understanding these concepts, how it works. So I have given here a GitHub link where a lot of examples are given here. Tutorial is there. Tutorial has MPI introduction also, very nice materials, pictures and all there. Some good understanding pictures for different algorithms. Scatter, gather. What is gather? Gather means something like this. Process 0, process 1, process 2, process 3. This process 0 is gathering red, green, blue things, right? In this fashion, it is getting messages. Think of message, this boxes. That way, a complete information is here, whatever required in the initial stages of your exercises. Please complete these exercises, then you will understand better. And I have some blogs here, sachinpbuzz.com, where you will get all the informations related to MPI things. This is a blog. Then anything I need to mention, I'm checking. Yeah, there are different supercomputers IBM has designed. So IBM started this supercomputer business in 2004. Blue Gene Roadrunner is the first one. Then Blue Gene came, Blue Gene series, LPQ. These are the Blue Gene computers. These computers were supercomputers were very famous because it was used to play chess, right, with the world chess champions. This computer won against the world chess champions also. That is a great thing. And what are the applications we are running on these supercomputers listed here? Who are the owners? All these things, details. Then HPC cluster in a multi-cloud environment. Nowadays, earlier, see, these computers are very huge, right? Only government organization like CDAC, DRDO and all, they can use or buy or create the infrastructure, but small companies can't go. So recently, Amazon come up with the HPC computes, EC compute nodes, where they are giving faster network adapters and CPU, GPU, virtual machines, and all. So small business people can make use of these resources available on cloud. So there are different types of cloud, right? All those things you can read here. Different vendors are here: IBM, AWS, Azure, Google Cloud Platform, OpenStack, Rackspace. So hybrid cloud, multi-cloud, everything is explained. You can have clear picture. Hybrid cloud is something there you will have a private cloud. Private cloud is a basically very secured one. Usually bank they opt for private clouds, and very what is the critical informations are stored in a private cloud. Other data is put in the public cloud. So mixture of public private is called hybrid cloud, right? Multi-cloud is different. You need to understand that multi-cloud is something different vendors, public, private, anyways there. Along with that, we have IBM vendors, cloud, Azure, then IBM, then AWS. Three things for different purposes, working together in the multi-cloud environment. That is the difference. Okay. Then then another thing, most of the people are looking at is big data analysis, right? So big data analysis is using a Hadoop kind of environment, Hadoop environment. So in the Hadoop, right, there is parallel programming, but it is a different concept. There you can use commodity machines. So you need not have to buy the supercomputers, but you can do the parallel programming, parallel computing. It's possible. Uh, so Hadoop was very famous, and many people are using this one. And let me show some of the architectures here. Uh, so yeah, it is altogether different topic. I am just comparing why HPC is not used in all the places, right? So Hadoop is the one which uses MapReduce algorithm. MapReduce algorithm is the kind of our reduce operations that we used in HPC, and a few similarities are there, uh, but in the Google environment, right? We can have both kind of thing. Hadoop is basically search engine where a huge set of data will be there, and each data is broken into small chunks, and each chunk is assigned to different processes, and each processes will search for the keyword that you are searching for. Then it will pick up the right value. That's how Google search is working actually. MapReduce is the one of the algorithm it is used. It is similar to HPC one, HPC reduce operation. That's what I wanted to convey. Yeah. Overall, I think I have covered everything. Any questions you can ask? Yeah. Yes. Yeah. So career-wise, some companies, right, like IBM, they have collaboration with universities. Some of the colleges are included. Uh, so there is a Open Power Foundation. Open Power means power hardware is made available open source. So many of the universities, like a few of the IITs and all, are using this one. So collaboration between the IBM and the university will help developing a lot of new features and fixing some bugs. That way we can relate HPC here. Okay, it was a nice experience that you have given me the opportunity to share my knowledge. And while sharing this, right, I am also getting some of the information from many people, and I am also growing in that way. So it is my interest to share my knowledge. You can go to my blogs, LinkedIn. You can add me to your LinkedIn group. I am posting a lot of information about HPC and other IBM related activities presently going on. Yeah, I thank faculty members and Shivagi Patil from the management side. Yeah, thanks. Bye.